We're the CSD Buddies group here to present our application that we made for our client, CSD Structural Engineers. So I'm Nathan. I mainly worked on our PC app and then various other backend things like the databases.
I'm Matt. I did full stack engineering on both the PC and the tablet application.
I'm Mia. I mainly worked on front end, but I did a little bit of database work.
Hi, I'm Jackson. I mainly worked on full stack development of the tablet app, primarily focusing on the back end.
And hi, I'm Bella. I worked with Mia on the front end for our tablet app.
Okay, so I'm going to talk a little bit about our client's problem. So our client is CSD, and they're a structural engineering firm. And part of their work is doing structural inspections in heavy industrial facilities. And these inspections involve going to a facility like, say, a steel mill and checking through the various buildings and runways to see if there's like safety problems or structural problems that need to be addressed. And the way they've always run these inspections in the past is to take handwritten notes in the field and like manually mark locations of observations on drawings of structures they've printed out and brought to the facility. And then when they get back to the office after the inspection, they type all of these handwritten notes into their database and manually mark up the drawings again with the observations. And then they use a Microsoft thing called a mail merge that generates reports using that database. So that's very time consuming. CSD has told us that for every 40 hours in the field, they plan to spend 35 hours in the office, like populating the database and generating their reports. But essentially all of the time that they spend in the office is like redundant and you can automate it. So automating that process is what we've been working on. And I'll hand things over to Bella to talk about how we've done that.
Yeah, thanks, Nathan. So CSD structural engineers came to us in hopes that we would make an app that would save them time. Kind of what Nathan was saying, it was a very redundant process and it was really time consuming. So this app is something they can use while they're in the field, which will then automatically be transferred into their database and used to generate reports. So their main requirements were to be able to import information about the structure and inspection before going into the field. So then from there, they can add observations that they viewed when they were at the structures. So a lot of their observations contain duplicate fields. So we were able to autofill the drop downs so that they could just go in and select things, and it was a lot easier. So we wanted to help them make the whole observation process quicker and easier. So I'll hand it over to Jackson, who's going to talk about our technology.
All right. Thanks, Bella. So the languages that we used, TypeScript is what we developed almost the entire tablet app with. We used that for our front end and the back end of the tablet app. So we had some TSX files where we had some components and then put those onto our pages for our front end of the tablet app. Our back end had TypeScript functions in a .ts file. We would just import those functions to handle the logic that we needed on those components. For the PC side, to handle a few pain points for our client, we developed a Python script just for simplicity and ease of development. The frameworks that we specifically used were React Native and Expo. React Native offers a very similar development experience to React, but is targeted to build onto an Android or iOS platform, as well as being able to build to a web system, which is perfect for our use case since we were developing only for Android tablets. Many of those same hooks that React provides that are very useful in front-end development are provided with React Native. So we particularly used useState and useEffect to keep our app performant, but also very responsive. We have a lot of packages that we took advantage of using the support of React Native. So React Native Paper was very valuable for us. This has a lot of out-of-the-box components that we were able to put together to create our own components, which saved us a lot of development time. Expo is the other framework that we use. Expo is essentially partners with React Native to build our code into the actual APK file that goes on the Android tablet. Expo also has several helpful packages that made our development much more streamlined. Expo Router is what we use to transition between pages and pass props between them. Expo File System interacts with the Android device's on-device file system, which is really useful for trying to get external files into our app. The database that we used is SQLite. SQLite is a pretty simple database solution for on-device storage and access. since our client is using our app in a situation where they're in a steel mill or some other construction site that is not guaranteed to have internet access, we need our data to be fully accessible while still being in that situation without any kind of Wi-Fi or wired connection. So SQLite allows for one user to access an on-device database. We used a package that came with Expo called Expo SQLite, which handles creation of a database and handles transaction management all for us. This worked very well for our use case. Finally, the platform that we're building for is an Android tablet. That is what CSD structural engineers uses in the field. So that way they can take their notes a lot more smoothly rather than just handwriting them. This was specified by our client. Now I'm going to hand it over to Matt and Mia to show a demo of our app.
Thank you, Jackson, for passing it over to me for the demo. So today for this demo, me and I are going to be CSD structural engineer and inspectors, and I'm going to be a supervising inspector. So I just got to the office. I'm setting up an inspection for the day. So I will go and I'm going to download our inspection template, and this is going to be in just any folder you want. So I put it into this inspection folder right here. I now have a bunch of different folders here, and what I can do is I will take our inspection template that I have pre-filled out and paste it into this folder. This is just an inspection that I wanted to do today for the company, and it has a bunch of pre-filled out stuff, like all of our different structures we'll be inspecting and some of the other important inspection information. So from there, I'm going to prepare this folder to go to the app. And the way you do that is you literally just select that same folder as before. And I will send that to the app and get it ready. And now it should be in this export to app folder. And from there, the last step I got to do is I have to take some key plans for this and put it into the export to app folder. Once they're there, we are all good to go. And I will now zip this file up and I'm going to send it over to Mia for the inspection on site.
So I'm an inspector going to the structure and I'm setting up the tablet, making sure it's all up to date. So I'll import the inspection that Matt has prepared. And then I see it has been imported. So I'll go into that. I'll click on it. I'll go to the area that I'm in today, which is the melt shop. And actually, I've noticed I talked it over with my team, and in the refactory maintenance runway, we've already done some observations, but one of them, specifically the serial number 4, is actually wrong. So I'm going to go click on that one. We don't need that one. So I'm going to edit it and I'm going to delete it. So yes, I want to delete this observation. And then I'm going to go back to the structures page, back to the melt shop. And now I'm going to start the observations for today at the melt shop runway. So I'll click on that and I'm going to add basically I'm going to walk around, see if I find any issues in the building, and I actually see one. So I'm going to add an observation. It is located at the supporting beam in the top left corner. So I'll write that out. I note that the material type is going to be steel members, and the deficiency is light corrosion. So all of that, as you can see, auto-populates. I'll click on the additional deficiency dropdown, and it is of the beam member. So I'm looking at that and I'm wondering actually if that recommendation is the correct one. I'm not entirely sure, so I think I might actually flag it for further review just so my higher ups can double check. Meanwhile, I'll also be taking a photo with the physical camera, and once I get that photo, I'll make sure to write down that observation photo number, and I'll take a second photo more detailed and write down that number. And then I will add the observation. And last but not least, I'll scroll down and I'm going to add the location on the key plan. So I'll set the location, I'll choose the correct key plan, and then I'm going to hit that area that I had mentioned before, that location, and I'll save it. So I will continue making observations. So I'll go back. I'll go throughout the day. I can see that it's flagged for review. So my higher ups know that that one should have a little bit more. I'm not entirely sure. So I'll keep walking around and I see another issue and I'll add another observation. And the location of this one is on the supporting beam in the middle. And then the material type this time is actually going to be concrete foundations. The deficiency is spalled concrete with exposed anchors, or yeah. And then that additional deficiency is going to be at the concrete pier. So the autofills are put in. I'm more sure about this one. I'm going to scroll down, take my photos, add photo numbers that are on the camera. And I will add that observation. I actually realized it looked a lot more serious, so I'm actually going to go back in and edit the priority to make it actually a P1, as in it is very dangerous and needs to be dealt with immediately. So I'll save that. I'll set the location of it real quick. It's one of the beams in the middle. And so I'll save that, view it, make sure it's there. And we see that it is. So then I will go back. I'll continue doing observations for the rest of the day. And at the end of the day, I'll be going back to the inspection screen. So Nucor Jackson, Mississippi. And I have forgotten if I had any P1 observations. So I'm going to click on that show P1 observations. And I see that we actually do have some P1 observations, that supporting beam in the middle. So before I leave the area today, the structure, I'm going to make sure to tell our client that there's a very serious issue that they have to deal with. And yeah, after that, after I already tell them about that issue, I'll go back, I'll export the inspection so that those back at the office can put it into our database. So yeah, I'll use this folder. And the export is complete. So yeah, I'll pass it off back to Matt at the office.
So I'm once again back at the office and I've gotten the import from app file from Mia and I unzipped it into this directory. So we can see inside of here we have an export database file, and I can also view a key plan that has the locations of some of our serial numbers on them. From there, I'm going to take the contents of this file and copy them into our import from app file. Once I've done this, I can now process this import from app. And so I'm going to go here. I'm going to find the inspection folder once again, select the folder. We're going to process it from the app. It's going to write all of our stuff into an Excel file. That'll be done. We can now go into our PC output folder, and I will see that there is now this output.xlsx file where we can see our new observations, and we can see the one that's flagged for review that I can go review. I can now mark it and say no after I looked over it. And from there, we can see the one that we removed as well. And then we can also go to the summary. See, we have 2 observations in the melt shop runway. And here on our list, okay, we're issuing a report today. So it's going to be 4/24, and then 2025 is our date for the report. We'll make sure to save this file. Once the file is saved, the next step is going to be to take our photos that we got that day on site, which we've already uploaded using our camera. We're going to take those photos and we're going to put them into the inspection and then the PC output directory and put them in this photos folder right here. Those photos have been pasted. Now that we've moved those photos, I'm able to actually generate the report from the inspection. So all that takes is, once again, I will go and select on that inspection folder. And now that I've selected on that inspection folder, we are going to have some documents generated, and we can look at our folder here. And we can see the observation pick photos right here, our observation that was made, And same thing for the second observation right here. Well, now it'll pull itself up. We have photos as well. And then it has priority and all the other information that we populated earlier on site. Thank you, Mia, for that. And finally, once we're done, we've looked at everything, it's all good to go. We want to finalize reports and put it into PDF report, which we can send to our client. What we do with that is finalize reports. I will find that inspection once more. Once that inspection is found, select the folder, and then it's going to take a little bit to generate all these PDFs from the Word documents. However, once that is done, we are going to have an overall summary. We're going to have all of our P1 observations. So first we'll take a look at this compiled inspection report right here. I'll bring this over. We can see it. Go down to all the issues. We can see where the photos are. We have our photos. These are our 2 issues that we added. And then the P1 observations. We have our P1 observation right here that we made inside this folder. And this is what we'll export to our client.
Thank you for listening to us talk about our app.